All right, good morning, everybody. This is your host and confidant, Adam Evangelista, back for another installment of Autodesk Virtual Academy. Hope you guys are having a good day. Today's what, the 24th of June so far, middle of summer. It's scorching hot in Southern California. Our special guest here today, Cameron, you're up in Utah, is that right?
That's right. Yeah.
Man, is it hot over there right now? How's it feeling out there?
Actually, it's been raining this morning, so it's nice outside.
It's been nice. Yeah, California is on fire right now and drier than ever. So um, yeah, I'm jealous. But thanks for being on today, Cameron. Yeah, we're going to be talking about advanced iLogic. You're one of our go-to iLogic people here at the company. You do a lot of the programming here as well. Some people have called Cameron the John McAfee of KETIV. May he rest in peace. But what do you got for us today, Cameron? What are we going to be talking about?
All right. So today we are going to introduce some more advanced iLogic tools that will hopefully open the doors to making your code more modular and reusable. And specifically, we're going to be talking about learning how to create functions and subroutines. Two tools that are part of the Visual Basic .NET, really .NET framework. And anyway, we'll show you what those are all about, how to create them, and what the difference is between a function and a subroutine. And then also we're going to talk about recursive functions and subroutines, a very useful tool to have in your tool belt. And we'll show how those work. They're a little bit abstract, but hopefully we'll demystify those and show you how powerful they can be. And we're also going to talk about how to create external rules and how to call them. And we're going to talk about how to pass rules and objects between your running rule and an external rule, or even between two different rules. And so, yeah, that's what we're talking about. So let's just jump into it. I'll stop my video here and we'll switch over to Inventor. One thing I do want to warn you about, I've been having some computer issues this morning. I've had a blue screen twice this morning. So hopefully that won't happen during this webinar, but you never know. If it does, then I will get back online as quick as I can. It'll take me a couple minutes to boot back up and get started, but we'll cross our fingers and hope that just isn't.
Yeah, fingers crossed. No problem. Yeah. Thank you, Cam.
Yeah. All right. Let me stop my presentation here.
And just a quick note before we get going here too. This is a Zoom webinar, so if you guys have questions or any kind of extra things you want to say, there's a Q&A, and we'll have chat as well if you need to submit any questions or concerns, right? And yeah, and there's also going to be a survey that goes out afterwards too. And we have plenty of reference material if you guys are interested in this kind of iLogic automation stuff, since this is quite a popular topic to begin with. Thank you. Take it away, Cam.
All right. Thanks, Adam. Okay, so what I've got here is just a simple little bracket that's got some iLogic rules in it to change the size. So it can either be small, medium, or large. As it changes, you'll see the length Z and the length X and the thickness have different values. And what I want to do is I want to have the description be display the values of the thickness and the two length parameters as part of the description. And what we're going to do is we're going to write an iLogic rule to automate that description for us. There's a number of ways you can do that. Obviously, you could export your parameters and use a custom property formatting and that sort of thing. But for today's purposes, we're going to use an iLogic rule to generate our description. So we'll start a rule. I'll just call it description because that's what it's doing for us. And this is a pretty simple thing. We just go into our snippets, go iProperties. There's one for description right there. We just grab that. And then we're changing that. We want to set that equal to, and I want to call it bracket. And then I want it to include the value of the thickness parameter. So I'll just put that parameter value there. And then I also want to include the length Z and length X. There we go. Okay, so pretty simple formula. We just save and run that. Go check out our description, our iProperties, and you'll see now it says bracket 0.5 by etc. Okay, so now let's say we actually want to, instead of just displaying the raw values for these parameters as decimals, as they are here, let's say we want to actually format those to be like fractional inches. And again, there are many ways of going about this. One way would be to use the custom property formatting in the parameters dialog, but we're going to just do that through our iLogic rule. And to save some time, I've got a bit of code that I've written up that basically takes that decimal value and formats it as a mixed fractional string. So I'll just copy and paste that code here. And then we'll just talk about it real quick. We take this value that we want to round, in this case, the thickness, and then we specify a rounding increment. So basically to the nearest eighth of an inch is what we have specified here. And then this little bit of code down here just takes that decimal value, extracts the denominator and the numerator, does some rounding and dividing, uses the mod function, and then basically builds a string that's a mixed fraction of that. And then we want to take that value as a mixed fraction and use that inside of our description instead of just the raw decimal value. So I'm going to take that, Control C, paste that there. So I'm going to use that in place of the thickness. So now we're still using the thickness that's being fed into this formula as the value to round. Formula goes through, rounds it, converts it to a mixed fraction string, and then we're going to take that mixed fraction, write it into our description. Okay. I don't want to spend too much time over that code because that's not really what we're talking about today, but I'll just go ahead and save and run that so you can see what the result we get. I'll pull up our description, and there we go. So now instead of 0.5, it now says 1/2. So we want to do the same thing for these other two values here. So let's go back into our description rule. And one way we could do that is we could, okay, so we've done this for the thickness. Now we need to do it for the length Z. So we could just take this whole block of code, copy and paste, and then change this to our, length Z or length X or whatever. That would be one way to do it. Obviously, this is going to take a bit more manipulation in order to get this to work, because we can't, you'll see we're dimming valued around here, and then we're dimming valued around here. All these other values that are being, we can't declare two variables with the same name. So we'd have to just either reuse it, by taking that out, just say, okay, now value to round is equal to this. We'd have to do the same here. We'd have to maybe go through some of this to adjust it. And then we'd have to do it again if we want to do the length Z, right? That would work. We could get that to work, but that's not the best use of our code, right? We're basically taking that same chunk of code and just writing it 3 different times. And let's say we wanted to change something. Oh, maybe the string needs to be slightly different format, so we go in and make a change to how the formatting is done. Well, we've actually got that formatting happening in 3 separate places, so we'd have to make sure we go through and fix it in 3 separate places, which is not ideal. So the better thing to do here, which is getting to what we're talking about today, is to use a function. And a function is a bit of syntax, it's a tool that lets us reuse the same lines of code over and over as many times as we like without having to rewrite that code over and over. I'll show you how that's going to work. So let's just erase this little second instance of what I pasted here. We don't want to end up doing that. We just want to reuse the same bit of code. So the way that works is usually down at the bottom is where we'll create a function inside of this rule. And the way we do that is we start just with the word function, let iLogic know, hey, we're declaring a function here. And then we tell it the name of the function, which let's call it decimal inches to fraction. That's the name of our function. And then get open parentheses, and then inside here we have to, it is possible to send values into a function. So like in this case, what we're trying to do is round a value. So we have to send it the value that we want it to round, right? So we could just call it value to round, just like that. Oops, value to round. And what we're doing is essentially we're creating a variable that is going to exist inside of this function. So we have to tell it what type of value it is. So in this case, we're doing it as a decimal. And then once the function is done doing its thing, we send it this value to round. It goes through and basically it's creating this mixed value, its fraction string. And that's what we're trying to get back. So a function is going to send a value back to us, and we have to basically declare what type of value we want to get back. And so we're looking for a string here, so we do it like that. And that's how you declare a function. And then you do always want to make sure you put your end function. It has to end with that. Now you'll see iLogic is complaining there's something here that's not right. It's got this red underline. And that's because when this iLogic rule runs, normally it just runs the code that's listed in this editor, right? But now that we've declared a separate block of code as a function, it doesn't know what code it's supposed to run when the rule runs, because a function can run as many times as you tell it to, but if you don't tell it to run, it's not going to run. But we have to, so yeah, iLogic is confused about which block of code it's trying to run here. So what we have to do, whenever you're going to use a separate function inside of your rule like this, you have to make sure that you tell iLogic, okay, this is the main block of code I want you to run. And the way you do that is you just call out sub main open and close parentheses. And then down at the end of your main block of code, so after we set the iProperties value, we want to make sure we do end sub. So everything between sub main and end sub is the code that is going to run whenever you hit run rule, right? And then any of your functions or subroutines that you declare outside of that, this function has to be outside of the this sub and sub block, okay? And any function outside of that is only going to run when it's told, when our code actually tells it to run. So now that we've declared that sub main, iLogic now understands, what this extra bit down here is a function, and so it clears out that little error. It knows what it's trying to do now. So, okay, so we've declared our function, and what we want our function to do is is just basically this bit of rounding right here, not the iProperties. That's going to be the main thing that our rule is doing, right? So that's going to stay inside of our main sub. But we do want to take basically almost everything else here, and we're going to cut that out and place it inside of our function. And then we're going to have to do some changes here to get this to actually work. So for one, the thickness, that's the value to round. We've actually already declared that here as a decimal, so we don't want to declare it again here, right? And we don't want to just assign it to be thickness, because that would just, every time I run, it would be thickness. That's the actual thing that's going to be changing. We want to run it once with the thickness, and we want to run it again with length Z, and then we want to run it again with length X, right? So that's the value we're supplying. So we don't need this line right here. Take that out. And now it's just going to use value to round, which is being used right there. And so that's good, but now we're not actually getting any values back yet, because we haven't told the code what to send back, which value we want it to send back. There's a couple ways of doing that. The most straightforward way is to use the return statement. So down here at the very end, after we've done all of our code and figured out what this value as mixed fraction is going to be, then we want to send that value back, right? So we just say return value as mixed fraction. And that's what will come back from our function. That's one way to do it. Another way to do it is to actually, when you're declaring your function here, you're actually declaring a variable with the same name as your function. That's going to be a string. And so you could, instead of doing return, you could do just use the variable that has the same name as your function. So decimal inches to fraction, and set it equal to the value we want to send back, which is value as mixed fraction. So that's going to assign this value into the function variable, and then whenever this function gets called, that's the value that's going to be returned. And that works just fine. I prefer not to do that. I prefer to use the return method just because it's clear. It's more obvious what's going on here. This is a little more abstract, and for someone maybe who's new to functions and subroutines and some of this stuff, is not very clear what's going on here. And so it's just for the sake of clarity, I just prefer to use the return value. So we'll do that. So we're going to return that mixed value. Okay, so we set up our function. Now, if we just run this rule, like I said, whenever you run the rule, it's going to run what's under sub main, and then only run the function, any separate functions and subroutines if they've been told to run specifically. Now, we have not told it to run this specifically, so if we just run it, it's just going to try and set this value here and not actually work with the way we want it to. So we have to tell it to run this function. And the way we do that is we just call the name of the function inside of our code. And then it's going to give us a value back. So we have to do something with that value. So let's just declare a variable here. We'll call it thickness rounded. And this will be a string, right? This variable is the variable type we're getting back. This mixed fraction is a string. And then we just set it equal to the name of our function, decimal inches to fraction. And so we're calling our function there, but we have to, when we call the function, it's expecting us to give it a value. So we have to give it this value that we wanted to round. So in this case, we're doing the thickness. So that's just the value we send it. The value of thickness. And so when this submain runs, it'll call that function, send it the thickness, it'll run through, calculate the mixed fraction, send that fraction back as a string. Will get stored into this thickness rounded variable. And then we want to use that variable, copy that, paste it here. So now we're going to use the value we get back from the function and place it there instead of thickness. Okay, so let's give that a try. I'm just going to save it. I'm not going to run it yet because it'll give us the same output that we already got, so we won't be able to tell that it's run. So I'm going to go in here. I'm just going to clear this out. So that's empty. So now we go run our rule, and then we should get the same result. So I'm going to open up our iProperties again. There we go. So now we've got same results as we got before, but now it's running through the function. And now that we've set up the function, we can reuse that same bit of code to get our other two values as fractions. So let's edit our rule here. So now we just have to tell it to do the same thing for these two. So we're going to basically just follow that same idea. Let's dim out a length z rounded as a string and set that equal to our function, some mul inches. And this time, instead of sending it thickness, we're going to send it z. Okay.
To clarify, Cameron, it looks like you're making the variables to hold the value of your function there. Can you just place the function into the third line there, the iProperties, and just paste in decimal inches to fraction for each of those fields? Or do you have to set variables? Yeah.
Nope, absolutely. That's a great point. Let's do that. So I do need to make sure I use this. So let's use that one there. But for this last one, we'll do what Adam's talking about. Instead of creating an extra variable, we can just call the function directly where it's needed. You would want to declare it as a variable if you needed to use it in more than one place. It would make sense to do that. But in this case, where we're just using it here in this final description formula, let's just do that. We'll just copy and paste just the name of the function, and we'll call the function right here, right in line. Of course, if you want to change this to length x, because we've already got z over here. So now we're calling length x. So yeah, so this is what Adam was talking about. We're just, instead of declaring a variable, calling the function, and then using that variable, we're just calling it at the moment where we need it, right here, when we're building that string.
Right, because like that.
This will call the function and then return the string and then just plop it right into that formula.
Beautiful, right on.
Okay, let me do that so we can see that whole line. Okay, so perfect. Let's try that, give it a run, and see what we get. Pull up our description. There we go. 1/2 by 5 3/4 by 8 7/8. All right. Let's do one other thing. Let's take a look at this rule that we made. Now, inside of our function here, we've got this round increment that's setting to round to the nearest 1/8 of an inch. But let's say we don't always want to round to the nearest eighth of an inch. Sometimes we want to round to something else. Like let's say for the thickness, you know, that we're buying some plate for that. And so plates come in increments of eighth of an inch. So it makes sense to round to eighth of an inch there. But let's say for these length X and length Z, that we want to actually cut it to the nearest 16th of an inch. Well, we can't do that here because we've hard coded this eighth of an inch into our function definition. So instead of doing that, let's just make this a variable that we pass to the function. So when we run it for thickness, we can send it an eighth of an inch. When we run it for length Z, we can send it a 16th of an inch. Okay. So the way we do that is we can just take this variable here. And so instead of just declaring it as a variable inside the function definition, or just in here, then what we're going to do is we're going to declare it as an argument that we're going to pass to the function, just like our value to round. And the way you add arguments is you just separate them by commas. We give it the variable name, and we have to tell it the type that it to expect, decimal. And now since we've declared it here, we don't want to declare it here. We certainly don't want to hard code it, so we'll just take that out. But now every time we call the function, if we ran this function now, it would throw an error because we've only supplied it one argument, but it's expecting two, right? So now each time we call this function, we need to make sure we send it both arguments. So for the thickness one, we decided eighth of an inch is perfect for that. So we'll do 0.125. But for the length Z, we want to do a 16th of an inch. And then we want to do the same thing for our length X. So I'll just copy and paste that. Now we've got our two variables we're sending to it, but we're still getting obviously the same value back, but now we're able to parameterize the round increments. So let's go ahead and run that and see the difference we get there. Now we see we've got these rounded to the nearest 16th. This one was already 7/8, so that didn't need to change, but this one did say what, 5 5/8 or 5 3/4, something like that. And then now it's more precise, rounding to the 16th.
Oh, very nice.
All right.
Yeah, we have a few questions here, Cameron, before we move on. One person's asking, does the function always have to have the data type at the end? I know like whenever you call the functions, it ends with like as string or as decimal. Is that always a requirement when you declare functions like that?
Yes, when you declare a function, it has to have a value type. It doesn't actually have to return a value, but it does have to be declared as a type. And this is a great question. It's getting into what we're going to talk about next, which is subroutines.
Right.
And a subroutine is basically like a function, except you don't give it a type at the end because it does not return a value.
Interesting. Okay.
And we'll talk about that next. So.
Right on. And just to head off this question as well, someone's asking, we're assuming that you could probably, can you establish a library of functions and subroutines for like all sorts of people to access?
Yep. These are great questions. We're going to talk about that. We're going to talk about external rules, which is exactly what you're talking about.
Thank you. Okay. All right, go for it, man. Thank you.
Okay. All right. So let's talk about subroutines. I've got a different, go ahead and save this guy. I've got another assembly here. This is actually one of the sample sub-assemblies you can download for Inventor. If you go to Get Started and then hit Open Samples, it'll open up a web page that's got different samples you can download from Autodesk. And there's different samples available for different versions. This is a 2021 example here. But it's got a whole bunch of iLogic rules and stuff in here. We're not going to really talk about the functionality of this assembly. I'm just using it as a convenient assembly to talk about some of the stuff we're going to talk about today. But if we have time at the end, I'll just open up a couple of these rules because this is actually a great example. This iLogic contains great examples of what we're talking about today. There's lots of use of subassemblies or subroutines and functions inside of this code here. There's a little bit more advanced stuff going on in some of these. So this is definitely, if you want to really dig into this concept and see it in action, this is a great sample to download and try out. But what we're going to do for this one is I've got this assembly, and I'm going to open up the bill of materials. And we're just going to flip through here real quick, and we'll see there's several components that have their BOM structure set to reference. And even inside of some sub-assemblies, there's a couple components that are set to reference. And what I want to do is I want to write a rule that just goes through this entire assembly structure from top all the way down to the lowliest part, and set all, basically remove all of those BOM structure overrides, and they'll no longer be set to reference, they'll be set to default. And so we're going to do that here, and we're going to use that as an example of how to use a subroutine, and we're also going to start talking about recursive subroutines as well. So let's just call this move override. Not a great name, but we're going quick here. So, all right. What we're trying to do here is write a rule that is going to set the BOM structure of all of the components to default. And so that's a pretty simple thing to do. Basically just going to use a for each to loop through all the different components in this document. So let's say we'll go, I'm going to, just for convenience, I'm going to dim up the assembly document and set that equal to okay, just for convenience. But really what we're getting at here is we're going to do a loop, a for each loop, and go through all of the component occurrences as component occurrence in this assembly doc. I just had it. Component definition dot occurrences. Okay, so all the occurrences in this assembly, we're going to flip through each one of them, and we're going to set its BOM structure. Comp.BOM structure. Set that equal to BOM structure enum dot k default BOM structure. Okay, so a really simple loop that just goes through all the component occurrences in this assembly and sets its BOM structure to default. So that'll remove any of those reference overrides. But now the thing here is when that runs, it's going to go through just the top level occurrences in this assembly. But we know that we've also got sub-assemblies that also have some of their components that are set to reference. So we need to be able to go down in and set those as well. And so one way to do that would be just to nest another loop in here. So we can say, all right, let's check if the component occurrence dot definition document type is an assembly. So we're checking, we don't want to try and do this on a part. If the component occurrence is a part, it's obviously not going to have any children. So, we're checking if it's an assembly first. And if it is, then we're going to do another for loop for each sub comp, etc. in, in comp dot definition occurrences. Like that, right? We could do the same sort of thing there and loop again. And that would work through the next level below that. But we've also got sub-assemblies of sub-assemblies. It's not going to go through those. Okay, so what do? Add another layer of nested for each loops? Sure, that would work. But again, what if there's another level below that and another level below that? Or, I mean, you could just plan out however many levels deep you have, you could just write that many nested for each loops. That would work just fine. But what if maybe you're trying, like one of the people asked, how do you make rules that can be accessed by multiple documents? Well, we're going to be doing that. That's something you want to consider. And for rules like that, you don't know what kind of assembly document is going to be coming in and how many levels deep it is. So you cannot plan ahead for that kind of thing if you don't know what you're going to be getting. So that's really not the best way to do it. We're not going to be nesting these for each loops like this. Instead, what we're going to want to do is this function, or this bit of code that's going to be looping through and setting the BOM structure, we want to set that as a reusable chunk of code that we can call as many times as we need. right? So that's like just like a function like we were talking about in the last example. But in this case, all we're doing is we're just setting the BOM structure. We don't need to get a value back. We're not trying to get some, mixed fraction string back or anything. We're just performing an action. And so in this case, we don't need a value back. So we could, what we want to do, what we want to use here instead is a subroutine, which does not give us a value back. Okay, so let's go ahead and set that up. So just like for the function, we just go down to the bottom of our code, and we want to declare our subroutine. And the way you do that is you just use the keyword sub, and then we give it a name. Set default structure, and then pass it any values. You don't have to pass values if you don't need to. You could just do that. If you were just saying like maybe displaying a message box or something, you don't need to send it any values. You don't need to get any values back. Then that would work just fine. But in this case, we are going to be sending it the value of which assembly to loop through, right? So we need to create a variable here for our assembly document. So let's do that. And because we're doing a sub and not a function, we do not declare a type. That's the difference between a sub and a function. Is a function, you have to declare a type, and you can send a value back through that. For a sub, you do not declare a type, and you can't get a value back from it. Okay? Well, that's not strictly true. There are ways to get that. Yeah, we're not going to get into that. You can send reference variables, but that's maybe outside of what we're talking about here today. But in general, that's the main difference. A sub doesn't send a value back, a function does. Okay, we want to make sure we get our end sub, but you'll see iLogic is complaining again for the same reason it was before. We've declared a separate block of code. Now iLogic is confused, which is the main block of code that needs to run when this rule gets run. So you always want to make sure you get your sub main up here. And you don't ever put anything in the parentheses for sub main. This is very much a thing specific to iLogic. This is how we tell iLogic this is the main block of code. Okay, so now it's not complaining anymore. We've got our main sub, we've got our subroutine we've declared down here. We haven't actually set it up to do anything. So let's do that. So essentially what this is going to be is this is going to be our little bit of code that just flips through all of the components in an assembly document and sets the BOM structure to default. So we'll just go ahead and copy this and paste it down here. Of course, we're not going to be doing, well, we'll talk about that in a second. All right, so before when we were running this, we were looping through all of the component occurrences in this assembly doc, which is this document. That's this assembly document that the iLogic rule exists in. But we also want to be able to call this subroutine on sub-assemblies. And so we want to be able to send it a different assembly doc. So we want to take our variable here that's going to contain our assembly doc reference and replace this assembly doc, because we're not going to be using that every time, just the first time, right? So we'll paste that there. So now we're going to send an assembly doc to this subroutine. That's going to loop through every component occurrence in that assembly doc's occurrences and set the BOM structure to default. Okay. All right, let's up here. So we're going to loop through each one in this assembly doc and set the BOM structure. And then for if the sub occurrence is an assembly document, then we want to do it again. And we're not going to nest this. So I'll take that out. Oops, I took my indif out. Oh, no, I didn't. There it is. So instead, we're going to just call this function now. And the way we do that, just like before, we just call the name of the function. So I'll copy and paste that there. And then we're going to send it the subassembly document. So in this case, that's going to be the component occurrence that we're actually looping through at the moment. And we want to actually get we're sending it the assembly document, not the occurrence. So we want to make sure we get the document from that. And the way we do that is go to the definition and then document. Okay, so now when we run this bit of code, it's going to loop through all the components in the top level assembly, see if it's set to, and just set it to default BOM structure, and then check, okay, is this occurrence that I'm currently working with, is it actually an assembly? If it is, then okay, we're going to go ahead and run this function, or the subroutine, sorry, and we're going to pass it the document that represents this current component. So we pass that, and then it's going to loop through, because it's an assembly, it's going to loop through all of the component occurrences inside that subassembly and set their BOM structure to default. Okay. So, and again, if we just left it at that, then that would, like if we just took that out, if we just left it at that, then that's going to go through the first level and then the second level deep, and that's it. And again, if we wanted to go multiple levels deep, we were talking about, oh, we can nest for loops. We don't want to do that. And we got around that here by actually just calling our function. We can do the same thing here. If we want to go into subassembly levels below this subassembly, then we can just call this function again, right? And that's what's called recursive. We're making use of this recursive function. It's called recursion. It's basically the subroutine is calling itself, right?
Mm-hmm.
So actually, let me uncomment that. I still want the if statement to check, because we still want to check if this particular component we're looking at is an assembly document, because we only want to recursively call the function again if it's an assembly document. But this is the part we don't want. We don't want to write another for each loop in there, right? Instead, what we want to do is call this function again. So we're going to, just like we're doing up here, we're calling the name of this function set default structure. And this time, instead of sending it the same assembly document, we definitely don't want to do that, because if we do that, we just got ourselves caught in an infinite loop. It's just going to keep going through that assembly document over and over and over and over and never stop. So we definitely don't want to send it the same assembly document. This time, we want it to send it the assembly document of the component occurrence that we're going through at the moment, right? So definition. So basically just like what we did up above, definition.document. But maybe to make this a little clearer, we could rename this to sub, just to make it clear we're not actually doing the same thing as what we're doing up here. We're actually working on the next level below that. So let me just make sure I've renamed that. So we'll go through each use of that. Subcomp. Hopefully that makes sense. So essentially what we're doing now is we've hit the first level of subassembly occurrences. We've called this function on it. So now it's looping through all of the occurrences of that subassembly. So it's going to go through those. Okay, that's a part. So it's not going to call the function again. It'll just set its BOM structure, move on to the next one, move on to the next one, go through. That subassembly is just parts. Oh, I was too many levels deep. Okay, there's the first one. So it's going to hit that one. That's a part. That's a part. It's going to flip through those. Then it's going to hit this one. Okay, that's an assembly. So it's going to say, okay, if it's an assembly, yep, it is. So we're going to call this function again. But now we're going to send it this assembly as the document that we're going to flip through. So then it's going to basically like open up this subassembly and go through, okay, there's a component. Oh, that's in a subassembly. So it's going to run the function again. And it's basically just like manually flipping through this tree here, right? We just expand it. Okay, now it's going to go through each of those components. Those are all parts. It'll just go through, set them all to default. Then when it's done, it's going to come out, flip through the rest of these parts, then be done, then continue on, then be done with this one. Then it's going to go on to the next one. That's an assembly. It's going to flip through it. Hopefully that makes sense. One other thing we can do to simplify our code here is this little bit of code, this for each loop, is doing the exact same thing as this for each loop right here. So instead of writing it out twice like we've done, let's just call the function. And so instead of doing this, what we could do instead is just say set default. Oops. Make sure. And this time we're just sitting at this assembly doc. So that's exactly what we were doing before, right? But instead of rewriting those same lines of code, we're just calling that same function, running it through with this assembly doc. It's going to run through, find any subassemblies, throw them back into the subroutine, and just run it over and over and over again. So we're using the same function over and over and over again, but we're passing it at each level of subassembly deep. We're passing it that subassembly instead. And so it has the effect of just kind of drilling down through the subassembly structure and hitting every component occurrence in the assembly structure that way.
Oh, that's pretty neat.
Yeah, this recursion is really powerful. It's kind of an abstract concept, and hopefully I've done justice in explaining how it works here. But it's really powerful to be able to do that.
Right.
And essentially, anytime you need to go through an assembly structure in an Inventor iLogic rule, recursion is going to be what you end up using. It's going to give you more bang for the buck than trying to predict how many levels deep you go and just write.
That's right. Yeah.
So let's run it. Make sure it actually works. Let's save it first, and then just to review, we'll pull up our bill of materials here, and you'll see components with reference. So there's several components at the top level assembly, and then in this next level assembly down, we've got a couple components there as well that are referenced. And so after we run the rule, those should be set back to, okay, no errors. They won't be set to default. Default's not one of the options here. Default is just basically just means, okay, use whatever the part is set to. So in this case, these ones are set to normal. That one's set to phantom. So whatever the part has as its BOM structure is what it's going to display. So now you'll see there's no reference ones in there anywhere. If I expand this, there's no reference ones there. They're all set to normal. So it worked. Are there any questions on that one, Adam, before we move on to the next?
Yeah, we got a few questions going on here. If you could pull up the code again. When you type C-type at the beginning of the line declaring assembly document, is it the same as this application.active document? Could you point out the difference there?
Okay, yeah, there's a couple things in that question. So this application, that's one thing you can do. This application.active document, that would do the same thing. It would get this assembly document, but it's not quite the same thing in how it works, right? This would actually get the active document, which would be fine for this rule. That would just work just fine. But let's say you're running a complex rule that's maybe opening up a drawing and making some changes there, or flipping over to another subassembly or something and doing some stuff there. Then your active document is actually changing. And so if you're using this code and expecting to get the top level document, but you've actually switched over to another document, you're going to get a different document back than what you expect. And so you're going to get unexpected results from your code. So I tend not to use active document unless that's specifically what I'm going for. Instead, I use this doc.document, which gives me the document that this rule lives inside of. And so I know, regardless of what the active document is, this document is always going to give me this assembly document.
Right. Okay. Yeah, so that's like more specific to what you're actually working on.
Yeah. So there's a difference there. In this case, they would both give me the same document back, but there's a difference in how they're functioning that can become relevant if you're doing
It's interesting.
different things. So the C type is just, that probably wasn't strictly necessary. I could have just said, that's just me being specific about the type of code. So I declared it as an assembly document. If you just call this document, you'll see it returns it as just a generic document class. But I'm just converting it into an assembly document class. That's what the C type is doing, is just converting the type from generic document to an assembly document. And I can do that because assembly document is derived from the document class. And I know for sure that this is an assembly document, so I can get away with just doing that. Obviously, if I tried to convert something that was a part document into an assembly document, Inventor's going to cry about that. But in this case, since I know it would work, because I know I'm working in an assembly document, I'm comfortable just directly casting the type. But like I said, this is not strictly necessary. This is just me being, I'm used to just being very specific about the types of variables I declare and what data types they are. But iLogic is usually pretty smart about that kind of stuff. Yeah, I could have just said, I could have even just left all that stuff out and just said this assembly document. That would be my variable declaration, and just say it equals this document. And that would work just fine in most scenarios. But the IntelliSense, like the stuff when you type stuff out like this, assembly doc, and I hit dot and it pulls up all these helpful things that I could possibly trying to get access to, that only works if you've declared it as a specific variable type. If you don't declare it as a specific variable type, that it really doesn't know what you're trying to go for, and so this IntelliSense might not pop up. So that's why I tend to be specific, is because I want to make sure it's doing exactly what I want it to do, and I also like to have that IntelliSense pop up. It's very helpful.
Beautiful. Okay. And then I know I'm not sure how we made these data sets available in the past, but is this something you have saved that we could share with the audience after the session, Cameron?
It isn't at the moment, but we can definitely look into making that available.
I got you. Yeah, no problem. Yeah, so we'll see if we can get something out. Have some people asking about just being able to, get these snippets themselves so that we can take a look at them closer on their own time.
Sure. Yeah, I mean, this one's simple enough that you can just kind of see. Obviously, we record these sessions and we post them up to YouTube later. And so you'll be able to pull this up and see exactly all the code that we've written here today. And also, this assembly is just, like I said, it's a sample set that you can try stuff on. The components that were set to reference, I did that manually just for testing this code. If you download this sample set, those components will be set to reference. But like I said, I just did that manually, and by just kind of going through here and picking some components, right-clicking, go to bomb structure, set them to reference. So.
And then I think this question might be a bit beyond the scope of the session, but the same kind of idea behind like recursive subroutines. Can I possibly apply that same idea to like item masters and vaults? We have someone asking, for example, if you wanted to go through an item master and look for all associated PDFs. I think that would be maybe like a vault side thing specifically, but can you comment on that?
Yeah, I mean, you can use that kind of recursion if there's ever any kind of like nested tree structure that you're trying to go through. Then that recursion, yeah, you can use the same concepts to, in this case, we're doing it to specifically set a property, right? But if we were just going through to read a property, you could do the exact same thing and just say, okay, go through each component occurrence and tell me what its name is, or something like that. That, as long as you've got some kind of a nested collection of objects, then you can use the same concept to go through it. So yeah, I would imagine something similar like that would work if you get access to those item objects through the API.
And is that like a Vault API thing at that point?
Yeah,
right.
Definitely.
Okay, yeah. So that's a good question, Claudia. Thanks. And we could definitely talk more about that if you're curious. We'll probably have to connect out offline though. And I don't mean to interrupt you here, Cameron. You had one more topic I think you wanted to cover here?
Yeah, I want to talk about external rules. So let's talk about that. Give me a second here to get my notes. All right, so we're going to switch back over to the bracket assembly. And so this description code that we were working through, like basically taking a decimal value and getting the fractional equivalent of that, that's something that could be useful, not just in this part document, but like a lot of part documents, right? This is something that could definitely be useful across all of your parts. And so, but right now we've written this iLogic rule in this part. This is the only part that has access to this useful bit of code right here. So the way we can make this available to other components to use is, like was suggested in the question earlier, we can make this an external rule that basically does the same thing as what this function is doing. And then because it's an external rule, basically what an external rule is it's an iLogic rule that instead of being saved inside of this document is actually saved not in any Inventor document. It's its own script file, like a text file essentially. It gets saved on disk. You tell Inventor where to look to find external rules. And then any document you have open, you can go over to this external rules tab, and then it'll be listed out. In fact, I've already got the one I did when I was prepping for this AVA. So we're going to basically recreate that one. But the way you set this up, the way you tell Inventor where to look for external rules is you go to Tools, And then this options panel right here has a little flyout. If you click on the actual word options, and it's got this, I don't know why they hit it, but they did. There's this iLogic configuration option. You click on that, and then this is a place where you can set up one or more different external rule directories that a vendor can look in. And any directory you have listed here is going to show up as like a folder over here. So you'll see I've got this set up as my AVA folder, functions, today's AVA, and then I've got a subfolder for external rules. So let's go open that up. So here's my AVA folder for today's AVA stuff. There's that external rules subfolder right there. And any script file that I've got listed underneath here is going to show up over here under external rules. So there's that one there. And we're going to add another one. And as soon as we add it, it'll show up over here and here. Okay, so that's all an external rule. This is just an iLogic rule that's been saved in a text file. And then we've told Inventor, hey, this is a rule. This is a place where you can find those. And so it makes it available to any other document. Now, if you're going to, that would only exist to, in my case, I'm the only one who can see that because that's on my local drive. But if you wanted to have a repository of external rules that are available to other people in your company, then you could set up either a network folder or a vault folder and just some kind of common shared location. Then anyone who has those access to those rules would be able to see them. They would also need to, each individual user would need to go into their iLogic configuration and tell Inventor to look at that specific folder. So let's go ahead and make a new one. So the way you do that is you can just right click and add external rule. And this is actually just going to create a TXT file. Well, it doesn't have to be TXT. There's also iLogic VB or just a .vb. But just to keep things simple and to make things easy to read, I just like to use TXT files. So I do want to make sure I'm in the right folder. So I want to go up one and go into my external rules. And this is good. Hopefully won't get too confusing that I've already got one in there, but we'll call it number 2. And then I am giving it .txt to be specific. That's the file type I wanted to use. And then, oh, am I not creating one? Did I click the wrong thing? Oh, I hit add. So that would be if you have one existing already, you browse to it and then it would pop up there. I want to hit create, my bad. Okay, now it's actually in the right folder. I'm just going to pick on that and put 2 in the name, just like I did before. There we go. And then, like I said, you do want to specify the file type because it can be any of those 3. So I specify .txt. So what it does is it creates that TXT file in that folder and it opens up the iLogic editor. And this iLogic editor is the exact same editor you use for normal rules. It's just we happen to be, the only thing that's different is where it's saving that code. It's a normal rule, the code gets saved in the file. For an external rule, the code gets saved in the external TXT file.
Yeah, and that's a really popular way to collaborate with this kind of stuff, because once it's in the external rules folder, you could just call them like regular functions and any other rule, correct?
Yep, exactly. So that's what we're going to do here. So let's go ahead and we'll save that. And all I want to do is I want to make basically the equivalent of this function here. So I'm just going to copy and paste what we've got going on in here and bring that over. So I do want that end if. Make sure I grab that. I don't need the return because that's going to work a little bit different in an external rule, and we'll have to talk about that. So I'm going to not copy that over. That return is specific to the .NET function command. So, okay, I'm just going to paste that in. All right, so now essentially this external rule is doing exactly what that other rule was. But there's a couple of differences here, obviously, right? So now our function, we had to pass it a value. In fact, we were passing it 2 values, the round value and the round increment, and then we wanted to get a value back. And so there's several ways of doing this. I see we're getting short on time, but I do want to make sure we talk about some of this stuff. It's important to know how to be able to pass values to and get values back. One way to do it is in your snippets. If you go to, shoot, where is it? It's not. I think it might be another. Yes, okay. So there's this thing called a map, which is a name value map that you can use. That's one way to pass values to a function. and that works fine, but you can't get a value back using that. So that's not going to help us here in the case of a function. It'd be fine for a subroutine type of thing where you don't need a value back, but we do need a value back. That's not going to work. So I don't want to spend our time talking about that. Another way to do it is to create a parameter inside the document, like a user parameter. You can store a value there, and then when you run your external rule, just say, okay, go read the value of that external parameter, use its values, and then maybe create a new external parameter to for the value that you want to send back. That works. I've seen people use that. It works just fine. The only drawbacks to doing, you can either use a user parameter or a custom property, or even something called a file or an attribute, an inventor attribute. Those would all three work. The drawbacks to doing that is you have to handle the creation and deletion of those temporary parameter properties, whatevers. So it can be a little cumbersome. And also, if you want to run this external rule on a document that is read-only, you won't be able to use that method because you're essentially dirtying the document to create a temporary parameter and then deleting that temporary parameter when you're done. And if it's read-only, it won't even let you do any of that. So that's not a possibility for those. So what I tend to use, which seems to work across the board, is what's called a shared variable, which is very much an iLogic specific thing. And you can find it if you go into your snippets and go down to variables. You'll see there's a couple of different things here. There's a shared variable. This is how you create a shared variable or access an existing one to get its value. That's what it means by set or get. And then you can also check to see if that shared variable exists. So that's good for your external rules. Before you run the rule, check to make sure those shared variables exist that it's depending on.
Beautiful.
Before you try to use them. And then also you can remove them when you're done. So the way this works is for like a shared variable, we want to be able to do the value to round and basically do this. That's going to use an existing shared variable. And then we'd also use one for round increment. And then we'd also want to create one. Sorry, I know I'm going fast here, but. So this creates a shared variable with that name and sends it that value. And this is expecting a shared variable with that name to already exist, and it's grabbing its value to use it. But that's only half the equation. We also would actually, on the side where we're using the external, where we're calling the external rule. So instead of maybe calling this function, we would instead call an external rule. So I'll copy and paste that.
Sorry, shoot. Sorry, Kevin. I didn't mean to interrupt. Go ahead.
Oh yeah, no, fine. Okay, so let's say shared variable. So before we call the external, we want to make sure we create that shared variable, which was called value to round, right? So we create the shared variable called value to round, and we send it. In this case, we're going to send it the thickness. Okay. We'd also want to do one for the round increment, but just to save on time here, we'll skip that. So we create the shared variable first, and then we want to run our external rule right here. And then we call our external rule name, which was decimal inches to fraction 2. That's the one we made. So that's going to run the external rule. And then that external rule is going to create, it's going to use the value we stored in value to round. It's going to create another shared variable. And we want to get that value back. So then we would say thickness rounded is equal to, whatever. Thickness rounded is equal to the shared variable that we called mixed value, fractional value, or something, whatever it was called, right? You do want to make sure that those names have to match up. I'm obviously getting sloppy as we speed up here, but obviously the value, the shared variable you create here has a specific name. When you call it from the external rule, you want to obviously use that same exact name. And when the variable that gets created in the external rule, we want to use that same name when we try to access that shared, because it's essentially creating this like temporary variable in the background, and we're giving it a name and giving it a value. And anything that's running at the moment that shared variable exists can have access to that shared variable. Even other documents would have access to it. So you could create a shared variable, open up another document, and it would have access to that shared variable. So that's the way that I get values to and from an external rule, especially if I need to get values back. It's kind of the only way to do it. reliably. So hopefully that makes sense. Sorry, we kind of ran low on time there. I wasn't able to expand on that as much as I wanted to, but
Yeah, no, totally okay, no problem. Yeah, we have a lot of good content on iLogic. Cameron has been featured on AVA a number of times, and so do you actually have a contact slide on your presentation, Cam?
no, I actually don't.
Oh, it's okay. So feel free to reach out to us. We have various lifeline and emails if you guys want to contact us. We have a lot more posts available online, and we actually have some other upcoming events right now. If you want to click on that link there, Cameron.
Yep.
And so a lot of people are talking about digital transformation. Of course, iLogic and some scripting and programming is only a small part of that conversation, right? You go ahead and scroll down a little bit for me, Cam. This is an upcoming event, so we're kind of talking at a high kind of executive level for the variety of different ways you could go transform your workflows into a more digital one, right? So not just automation, but we're talking about like using generative design or leveraging machine learning inside of your processes. It's obviously a pretty large topic, but we'll have some heavy hitters there during that conversation. So feel free to our page over here. And of course, if you guys have more questions, there is a contact us page over here. If you want to click on the contact button in the top right, there's some contact info you could get for us for sure. If you guys want to talk to us and ask more questions about iLogic or digital transformation or what have you, I'll even paste
if you want to see that events page, you can just go to ketiv.com/events.
Yeah, I'll paste the event link right here. In fact, feel free to sign up if you guys want to talk a bit more about digital transformation as it applies to the manufacturing floor in particular. And so apologies we weren't able to get to all the questions over here, but thank you, Cameron, for another fantastic session full of good information. And I think from there, we'll go ahead and cut it and we'll reach out to the people and hopefully we'll try to make this data set available for people to consume afterwards as well. So any last words here, Cam?
No, that's great. Thanks, Adam.
Beautiful. Yeah, thanks everyone for being on here, especially you, Cam, and we'll see you guys again next week. Thank you.